So this video is about PSpice simulation of Cadence OrCAD, and here we'll discuss a difficulty level 1. We'll start with simple circuit. We'll try to understand the tool first, and yeah. So the first topic we'll cover in this tutorial is DC sweep simulation for a simple circuit. Then we'll see its results or its plots, and we'll pick particular values, and we'll see how to extract values from a DC sweep plot. Third thing, we'll discuss PSpice part search window. So that is again a new part search window on 17.4, and I'm going to show you that as well. Another thing is AC sweep simulation. So we'll also do AC sweep analysis. Then we'll see how to edit existing simulation file settings. After that, we'll learn how to plot, how to do Bode plot of phase margin and gain margin for a particular circuit. Then we'll learn transient analysis and its simulation. After that, I'm going to show you a couple of settings of plots, like how we can put multiple plots in a same window and etc. So these are the couple of points I wanted to discuss in this tutorial. So this tutorial will be a little bit bigger. But yeah, but before starting, I want you to put what topics we should cover, or what type of circuit you wanted to simulate in PSpice. So just put your comments below this video, and I'll try to include those circuit on upcoming videos. So with that said, let's roll the intro. So we're going to start with first type of simulation on PSpice, which is DC sweep. So for that, let's open our Capture CIS, and here I'm going to select with PSpice and CIS. You can also go with PSpice if you have only this license, but yeah. If you are using light version, you can go for light version as well, because today I'm not going to discuss like a lot of interconnects. So there will be small circuit, and we'll do those analysis. This is our start page. Now I'll click on File and go to New Project. Now here you have to enter what name you want to put. So let's start with, this is our first project that we are creating on for PSpice simulation, and I'm going to save it on desktop. Let's create a folder, PSpice projects, and inside that I'll create first project folder and select folder. Now enable PSpice simulation. So this should be clicked, right? If it is not clicked, it will be just normal schematic design window. All right. Now here you have to select if either you wanted to use some existing project, or you want to go with blank project. I wanted to create a blank project here. Press OK. All right, so stage is set. Now here you can see, this is what I wanted to tell you about 17.4. So before 17.4, if you have any older version 17.2, you have to add couple of libraries from default library provided by Cadence. I'm talking about specifically PSpice libraries. So to do this simulation, which we're going to discuss today, you have to add couple of libraries. First is you have to just click over this add button, right? And here you have to search for library which is eval. Okay, so you have to add eval library. If it is not here, you have to download it from somewhere and add it. So for example, eval p. Okay, so similarly you'll find eval library. In my case, I don't have that because I don't need it. But yeah, in your case, if you if you are using 17.2, you can able to find that inside your PSpice library section. Then another library I wanted to add here is analog. So similarly go for analog library. It should be there. Here it is, right? So you have to open this, and it will be like automatically added. So it has like all the basic passive components like capacitor, resistor, inductor, etc. Another library you have to add is voltage source. So for voltage source, you have to just check for library source, search, it should be there. Here it is. Okay, so you have to add that. So this is these are all the libraries you have to add. Now how you can select component, here you have to search all the component by holding the control key and select all of these, right? These are all the method for 17.2, but for 17.4 it is slightly different. So I'm just going to close this window. This is PSpice part search, right? If you can't able to see this window by default, right, let's suppose it is closed, it's not there, from here you can do that. So this is our launch PSpice part search, and here you'll get all the, so what you have to do, you have to just select this, and here we'll search all the components, right? So this is our, like, all the categories are selected here. If you'll see, it has like every type of simulation models that we need for simple and even complex circuit. All right, so we'll start with our voltage source. So for adding a voltage source, you have to just search here VDC. For 17.2, you have to search inside this panel, right? After selecting all of these together using control. All right, I'm not going to tell this again and again, but yeah, you can do that there, and just click on this search bar. Here we'll get DC voltage source. We'll double click on this, and by holding the control, and if we'll scroll in, we can able to zoom this window and mode. All right, so this is our voltage source that we have added. Now we'll double click and add voltage. So on this one, if I'll double click, I can able to change its value, right? So I'll go for 1 volt. Press OK. So we have added our voltage source. Now we're going to add 3 resistor. So I'm just going to create a simple voltage divider circuit, and we'll do DC analysis, DC sweep analysis for that. Let's add resistors here. So we have to search resistors. And here we'll get couple of pull-ups, pull-down resistors of different voltages. We want a general purpose resistors. So we'll just double click on that, and we'll place 3 number of resistors. And if you want to rotate this particular component, you have to just press R on your keyboard and right click end mode. Okay. So these are the 3 components that we have added. Now we're going to make connection between these components. So for that, if you'll hover your cursor on this particular tab, this is our place wire, right? So you can place wire through shortcut W, and or you can just click over this one, and let's connect all these together. All right, and I'm going to add some extent of wire here, end mode, end mode. Okay, you have to click end mode twice, otherwise you'll just keep routing tracks here. Now this circuit is incomplete. Why? Because we haven't added any ground on this one, right? So for ground, we'll just left click on this one, and here by default cap sim is selected, right? So we're going to use this same ground as well and place it here. Okay, so for different there are different type of ground, and we're going to learn that when we'll go for like some complex one, and when we'll see the application of those different grounds. But for now, we'll just add this cap sim ground here. Okay, so this is our first circuit, and which is kind of complete now. So now the next step is we have to add simulation here, right? So for adding the simulation, this is our first simulation for this particular project, right? So you can add multiple simulation for our different projects that I'll show you later. But this is our not shortcut, but a tab where using that tab we can able to add simulation profile for this particular circuit. So we'll just left click on this one. Now we have to name this. So this is our DC sweep simulation. So I'm just going to name it sim DC. Okay, and just left click over create. All right, so this is our simulation settings for sim DC simulation file. Now I'm going to edit this setting with some inputs from our side, that is whatever we wanted to simulate for this circuit, right? I'm not going to discuss everything in a single video because that will be like a very long video and lot of options that we can discuss here, but we'll cover those one by one. So we'll start with simple DC sweep. Now right now by default it is time domain or transient analysis type, right? I'll just left click on this tab and we'll select DC sweep here. Now we'll get couple of options. So this is option is primary sweep. Okay, what is the type of voltage? So we are using voltage source here, not current source or any global parameter or temperature parameter. What is the name of this voltage source? It is V1, right? So we'll just put that name here. Now other information we have to put is what type of sweep analysis you wanted to do for this circuit. Okay, so we wanted to do linear analysis for this one. You can do logarithmic as well, or you can just add multiple values. For those values you wanted to see what is the voltage across particular probe, that we're going to see how we can add probe. But for now I'm going to go for linear analysis. What will the start value you wanted to put for this DC analysis? I wanted to do this analysis for, so right now the voltage is 1 volt, but I wanted to do the analysis for minus 10 volt to plus 10 volt. So for that, start value will be minus 10, end value will be 10, and increment, what will be the increment you want to go for? So this will basically define the resolution of your plot. So in our case we'll just start with 0.1, otherwise it will take a lot of time to simulate. Maybe it depends on your system specs. Now we'll just click over apply. Okay, so we have created a simulation file which is inside this one. Okay, simdc. All right, you can delete that, and if something entered wrong, you can edit that simulation file anytime. I'll show you how, but for now this is done. All right, now the next step is we have to add probes wherever you wanted to measure voltage. All right, but before adding probes, let's play with some values, some of these values. So this is 1K. I just want to show you how you can change resistance values. Just double click on value and you can change it, and let's make it 3K. All right. Okay, now I'm going to put probe. So for putting probe, this is our tab that we're going to use, which is, if you'll hover cursor there, it is voltage level marker, right? You just select it and put it on this R3. All right, so this is our you can say a single-ended probe. So whatever voltage we'll see on this probe will be with respect to ground. Okay, now let's suppose we have to add a differential probe. So for that, if you'll see here, this is our differential probe marker, right? We'll just left click on this. So now it is asking for positive, where you want to put positive of this one, so we'll put here. Where you wanted to put negative of this one, we'll put here, right? You can see it, if I'll zoom in, you can see it is V plus and V minus, and this is just V, right? So this one is with respect to ground, and this is the difference of these two. So here whatever we'll see on plot for these differential probe, it will be the voltage across R2, and here we'll see the voltage across R3. All right, so we have added probe here. Now the next step is we have to run the simulation. So for running the simulation, we have run PSpice simulation button here. Let's click on that. All right, so our simulation is ready. Just make it bigger. So you can see this is a kind of simulation that we have done, and here you can clearly see this green one is voltage across R3, okay, and red one is voltage across R2. Okay, so this is the second pin of R1 and second pin of R2, right? So you can see here as well the color is changed. So from there we can able to understand, okay, this red plot is for R2 and green plot is for R3. And we can see from -10 to +10 input voltage, what is the value of voltage across R3 and R2, right? So let's suppose I wanted to check the voltage across, what is the voltage of R2 and R3 at 1 volt, okay? So here you can see it's like kind of difficult to see because a lot of things are missing. It's just 0 to 5 and this. So what we'll do, here we'll have this toggle cursor. We have to just select it. Now if we'll click here, we can able to move our cursor for a particular plot, right? And here you can see the voltages or the value of this particular cursor. So right now at this particular point, the voltage on red is 0.751 volt, okay, and voltage on green is 0.375 volt. All right, so if I'll move it a little bit more, we'll just set it for 1 volt. All right, so this is our 1 volt, sorry, the voltage. So these are the voltages, okay, I mentioned that wrong. So this is the voltage on voltage across R3, this is the voltage across R2, right? So on R3 we'll get around 0.51 volt, and on across R2 we'll get 0.340 volt, right? Similarly, you can add multiple cursors on this one. If you want, you can add multiple text labels, and there are a lot of other feature of this plot. For example, you can see the report using this one output file, and okay, there are a couple of things like we can add another traces as well, or we can put this particular voltage inside multiple functions that we'll see after some time. But yeah, this is our first circuit simulation that we did, which is DC sweep. Alright, so let's move to another type of simulation that we're going to target here, which is AC sweep. So I'm just going to close this one. Alright, so for AC sweep, I'm going to add another sheet on our schematic. Just let it be. But before going for another simulation inside the same project, I would recommend to delete all these probes. Alright, let's save this our project. Now right click over schematic and add new page. What you wanted to name this? Let's go for AC sweep. Alright, on this one we're going to simulate a simple RC filter, okay? But so on RC filter, the first thing will be general purpose register. Let's place all the component first. Let's zoom in a little bit. So this is our another component. Let's search for capacitor. Double click on this, press R to rotate it, and mode. I'm going to use this, let's go for 1 micro. For micro, we'll use small u here, press OK. Now we're going to add an AC source. So VAC, let's see if we got it, or we have to search for VAC. Alright, double click on this, let's add this VAC source. Alright, now if you observed one thing on this VAC, it is asking for two information, right? One is AC voltage, another is DC voltage, right? So in our case, we're going to simulate this for an AC voltage, not DC voltage. All right, we'll just let it be 1 volt, and we'll just for DC we'll not use any DC voltage here. Let's make it 3 micro, okay, because I've done calculation for that. All right, now let's make all the connections. double end mode. Now we'll place our cap sim ground, and so this is what it is given here. All right, now so here we have two options. Either we can edit the previous simulation settings or we can create new. In our case, we're going to create new simulation setting for AC sweep. So whatever I told you, we'll left click on this one. We'll just name it sim AC, create, and like we did last time, if you remember, here we have to select AC sweep. Now for AC sweep, we'll go for logarithmic type of simulation, not linear one. And here we have to enter the frequency of this source. So whatever the source, we have entered the voltage only, right? But what is AC source? AC source has voltage as well as frequency, right? So what should be the start and end frequency you wanted to see the simulation for, right? We'll enter those values here. So I want to go for 1 Hz to 10k Hertz, and these are the points, right? So we'll simulate for these many number of points. So we'll go for 1000 points first, and we'll just leave this noise analysis for now. See, this Cadence or PSpice tool is really useful and really powerful tool. So we can't able to discuss everything in a single video. So that's why I'm leaving this for now. But yeah, we'll discuss that in very detail very soon. All right. Now click apply and OK. Now what is another step? Another step is add probes. So now the next step is we have to add probes. So on this particular circuit, we're going to add probes for output voltage across. We wanted to measure the voltage across this capacitor, right? Because this is a low pass filter, so we can able to understand, okay, so the voltage for lower frequency, we have to see what is the cutoff frequency that we can get using couple of plots and couple of functions. I'll show you how, but you can able to simply understand for lower frequency there will be high voltage on this one, and as soon as we'll increase the frequency, the voltage across this capacitor will be going down, right? So this is what we are expecting from this plot. Let's add a probe here, end mode, and run the simulation. Okay, it's ready. All right. So as you can see, whatever I told you, for 1 Hertz to some I guess so this is like whatever the calculation we do for cutoff frequency, fc is equal to 1/2 pi r into c. So from that we'll see we have 1 and 3 microfarad. So it will be 6 to 3 20. Okay, so it will be around some 50 to 50 hertz of frequency. That will be our cutoff frequency, right? You can calculate that if you want using normal calculator, and that you can see after 50 or whatever the cutoff frequency is, the voltage is going down very rapidly, right? So this is what low pass filter is, and yeah, we got this this thing here. Now here I wanted to show you couple of things. So from this, how we got to know what is the cutoff frequency by seeing this plot. One thing is just doing the calculation, but let's suppose we are dealing with a complex filters, okay, and we are simulating some plots for frequency and voltage, and their mathematical calculation will be little bit difficult, right? So now from plots, how we can able to understand that? So if you remember, if what is the gain margin for a RC filter? That is -3 dB, right? So on 3 dB, whatever is the whatever the frequency is, that will be our cutoff frequency. Similarly, let's suppose we are simulating for phase. Then for simple RC filter or low pass filter, what is the phase? If you remember from your graduation days, it is 45 degree, right? So we'll see at 45 degree what is the frequency, and that will be our cutoff frequency. So let's see that how we can able to do the Bode plot for phase margin and gain margin. So for this thing, okay, so for you, what you have to do, so this V R4 2, that is clickable. Okay, so we can able to click on that. Let's double click on this thing, and this is the trace expression. This is the expression that we have plotted, right? Now we'll copy this, Control C, and we'll select dB, and inside the bracket we'll paste it, and this dB is decibel value. Okay, so this is this will calculate gain, right? And we'll click OK. Now, so this is the gain in dB from 0 to -60, and we'll use our cursor. We'll see for 3 dB, so it is going down here, right? We'll see for 3 dB what is the frequency. So for 3 dB it is across 53 Hz. So this will be our cutoff frequency that we got to know from gain margin. So similarly, let's do the simulation for phase margin. So we'll double click over this again, and we'll copy this internal expression. Control X, we'll just cut that. Now we'll select phase. So for phase, you'll see a function P here. We'll select it and Control V and OK. So this is our phase margin. Now we have to select for 45 degree, right? So I guess it is already selected. Our cursor is set as 45 because the cursor is same as previous plot, and yeah, you can see for 45 degree we are getting the cutoff frequency of 53 Hz. So this is a kind of AC sweep for a simple low pass filter. All right, similarly we'll see later how to use another other functions, other trace functions that we can use to do a lot of analysis. And yeah, let's move to our transient simulation. All right, let's move to another segment of this tutorial, which is our transient analysis. So we'll just close this plot, and we're going to create another page. So I'll just delete this, right click, new page, and this will be you can mention transient. All right, okay. So on this one, firstly we'll just save this complete project. I'll share this project in description. You can just download from there. Okay, so firstly we'll put resistor and capacitor. We'll go for this same RC filter. So one will be resistor, double click on this. Okay, whatever. All right, let's zoom in a little bit. End mode. Just search for capacitor. Search, go for general purpose, double click, press R to rotate it. End mode. Let's make it 3 micro like before. Okay. Now here we're going to add sine wave as a source. So to add sine wave as a source, we have to search for VSIN. Double click on this and put it here. All right. Now before making connection, we'll just edit this property. So here it is asking for a couple of parameter, which is V offset, V amplitude, frequency, and what is AC or AC voltage of this particular simulation of this particular source. So we'll double click on this one. We'll just leave it 0 volt. Amplitude will make it 1 volt. Frequency will go for 50 or 60 Hz, whatever you want. And this also will make it 0 volt. So in PSpice we can do transient analysis with AC sweep. So that's why this AC voltage they are asking here on source. Alright, so we have entered all the values correctly. Let's make the connections here. And wire. Now we'll place ground, which should be same as before. This cap sim ground, sorry, end mode. Now next step is we have to add simulation profile for this one. So we'll just add new, or you can edit the older one. So we just left click on this one and just name it sim trans for transient, create. Okay, so there shouldn't be any space. Create. Now in this setting, it is already set by default, time domain transient analysis. Now we have to enter run to time. So if you know from this, we can able to see the tau value, and so it will go for 5 or 10 cycles of this one. So for that, we'll enter run to time is 0.1. Okay, 0.1 second, and start saving data after. Okay, so here we have to enter, after which okay, so we'll leave it for now. We'll start data saving from 0. Here we have to enter the maximum step size. Okay, so this will define the resolution again. So we'll go for good resolution. We can go for 10 microseconds. All right, for micro we'll use small u, and yeah, these all the things are done. We'll just apply and okay. Now we have to add probes. So for adding probes, we're going to add probes on V in and V out. All right, and we'll see what results we'll get. And next step is we have to run the simulation. So simulation is ready. All right. So as we have discussed, this is again a low pass filter, and here we can clearly see the phase difference of 45 volt. So here you will see you can't able to see, this depends on our start condition, but from here, and I have told you we're going to put 5 cycles. So 1, 2, 3, 4, 5 cycles are added here that we have calculated, and this is for 60 Hz, right? Still we are getting some voltage drop here, which will be across if we'll measure, we can measure that, but if we can, for now we'll just guess it. It is 0.5 here, and this will be across 0.2 to 0.3 volt drop because of frequency, right? Because the cutoff frequency is 53 and we are going for 50 Hz, right? But still there is some drop because it started after, if you recall the older plots, it started after 30 Hz, right? So yeah, these are all the things. I guess that is a good start for PSpice simulation. And on next video, what you want me to discuss, you can just put your suggestions in comment section. So I'll try to include those circuit, those filters, or any converters you wanted to see see on next video, so that you can comment. And yeah, that's it for today's video. Thank you.